Hi, welcome to another episode of Algebra in Words. Today's topic is order of operations, something very important that you need to know for all the algebra that you'll be doing going forward, every type of problem. And what I want to focus on first is the acronym that's used to remember how to do order of operations. PEMDAS versus what I use, GEMA. PEMDAS is the traditional acronym that is often taught in elementary school, and if it's not taught properly or if it's not remembered properly, it can lead you to little minor mistakes that can lead to big mistakes. I don't recommend PEMDAS, and I'm going to explain why. First, let me explain what GEMA, the acronym, represents. G-E-M-A. G stands for groups, E stands for exponents and radicals, from inner to outer, whichever comes first from left to right. Then M, multiplication, which also stands for multiplication or division, whichever comes first from left to right. And finally, addition or subtraction, whichever comes first from left to right. Now, why do I use GEMA, what I just explained, instead of PEMDAS? Why do I say PEMDAS is not wrong, but can be misleading? I'll explain why. If you go by PEMDAS and you read it as chronologically, first of all, you have P, which represents parentheses. But there's many different types of groups besides just parentheses. Okay, I have a few problems on the board. We're going to go over one or two now. I might go over one and erase the board so I have more room. But for example, okay, if you look here, this is a parenthetical group, a group with parentheses. But you also can have parentheses within brackets. Brackets are a group. You can also have a group of brackets within a larger group of braces. That represents a group as well. So in this case, you would work from the inner group to the outer group. In addition to that, there's other types of groups you may not realize too. If we look up here, this is a radical. The numbers or terms under a radical, which is called the radicand, we'll do that in a later lesson, under the radical represents a group as well, so you would have to simplify under the radical before any other step. Also, if you look here, this is an absolute value group. That represents a group as well. And there's actually two other groups here that you also may not have realized, a numerator and a denominator. And if there's multiple terms in a numerator, an overall numerator, and an overall denominator, they constitute individual groups as well, and would need to be simplified by themselves as the first step of order of operations. Okay, so that's very important. That's one reason why I don't like PEMDAS, because it uses P, but there's other groups besides P for parentheses. Okay, secondly, what happens when we look at the E and the M? Okay, what about the E? The E represents exponents. Now, true for the E that I use in GEMA, I use that to represent exponents and radicals. Okay, there's not an R for radicals here, but the reason why it's important to remember exponents, it's important to remember that exponents can also be converted into radicals as a rational exponent. That's another topic that we'll go through in a later episode and you'll learn at a later point in class. But next, what about M and D? Okay, the way that it's written in chronological order here might lead some students to think that you do multiplication first, then division. But that's not true. Multiplication and division need to be treated equally. Multiplication or division, whichever comes first from left to right in a problem. Okay, if we look at one of these problems, for example, say here, okay, multiplication comes, there's no division. Okay, in the case of this, we would simplify the top individually, we would simplify the bottom individually, but then once they're simplified, the fraction bar represents division. That would come next, alright, and obviously there's some multiplication and exponents under the radical, but again, that overall numerator would be simplified first. And then finally, the last order would be addition. Okay, one other thing I want to say about multiplication before I go on is, what you need to remember is, multiplication and division can be interchangeable in the sense that you can multiply a term by a fraction, and multiplying a term by a fraction is the same as dividing by the denominator of that fraction. Okay, so that's one way to keep in mind that multiplication and division should be treated equally, because they are, depending upon the form that they come in. And finally, the last order would be addition. Okay, in PEMDAS it shows AS, and again could misleadingly let you think that you do addition first and subtraction last. But again, that's not true. Addition and subtraction need to be treated equally, whichever comes first from left to right. If we look at these problems here, suppose we look at the problem at the top. Notice from left to right, there's subtraction and then addition. Okay? If you follow PEMDAS, you might be led to think that you do the addition before the subtraction. But that's not true. From left to right, you have subtraction first, which you would perform, and then addition, and so on. Okay? So why do I have it reduced to just these 4 words? Well, I explained groups, I explained exponents. We'll go into exponents and radicals and rational exponents later. I talked about multiplication in that you can multiply by a fraction, which is the same as division. But finally, what about addition? Well, if you think of addition, you can also add a negative number. That's the same as subtraction, so that's another way to keep in mind that addition is sort of equal to subtraction. Okay, so that's why I don't use PEMDAS and why I like to use the acronym GEMA. In the next video, we will simplify a few of these examples. Thanks for watching. If you like this video, please give a thumbs up and please share with your friends. Thanks for watching. Until next time.